Hey there, welcome back to the channel. I'm Blake Green. I'm a cloud architect and AWS community builder. Today we're going to be going through the serverless stack. So this is a sort of a workshop that we go through and learn how to build a full stack serverless application. It's a totally free website and workshop. You can go to it by serverless-stack.com. And with that being said, let's just go ahead and dive in. And there's a button here that says Start Learning. And there's a couple of different, I'd say, like, avenues to go down here. There's the basics, so the best practices. There's a lot of content in here to sort of go through, but I think it'll just be fun to start at the very basics and go through and see what this course has to offer. I found this course by they recently came out with a new tool. I think they linked to it here somewhere. But it's essentially like hot reloading Lambda, AWS Lambdas, like through your local development. Yeah, I think it's here actually. Maybe not. Anyways, I saw a Twitter post about them doing something really unique with locally developing Lambda functions, and then I noticed that they have this this whole workshop course, and it kind of fits with everything that we've been doing so far through the live streams. So yeah, I think we'll just go ahead and jump in and see what we can get done today. Like I said, this is only part one. Obviously, there's a lot of content, so I'm going to try to just get through as much as possible, and then we'll see where we go from there. But yeah, so who is this guide for? This guide is meant for full stack developers or developers that would like to build full stack applications. Bump up the font on that. But by providing a step-by-step guide for both the front end and back end, we hope it addresses all different aspects of building serverless applications. There are quite a few other tutorials on the web, but we think it would be useful to have a single point of reference for the entire process. And like I said, when we kind of were going through the table of contents, you could see the depth of different areas that this covers. So looking forward to going into that. But basically, it's meant to serve as a resource for learning how to build and deploy serverless applications, as opposed to laying out best possible way of doing so. You might be a back-end developer and who wants to learn the front-end portion, or vice versa, right? This is catered solely towards JavaScript developers. So we'll see about that. So yeah, seems like really fun. Let's keep going. What does this guide cover? To step through the major concepts involved in building web applications, we're going to build a simple note-taking app called Scratch. However, unlike most tutorials, your goal is to go into details of what it takes to build the full stack application for production. So here's a screenshot of what it looks like, what it'll eventually look like. Looks pretty clean, There's a mobile version of it as well. But like it says, this isn't like the goal is not to see like the prettiest or coolest looking application. It's the concepts that you go into building this application. So Some of the technologies that we're going to use are Lambda, API Gateway, DynamoDB, pretty much, everything you would, use in a serverless application. We're going to use Route 53, Cert Manager, CloudWatch. It looks like we'll be using Netlify a little bit too for automating React deployments. So perhaps like the front end will be hosted on Netlify. We haven't used Netlify yet, so. All right, so using free tiers, and so it shouldn't cost hardly anything to run this. So some requirements for this guide are, have a node installed, a GitHub account, and some basic command line knowledge. I think we're pretty covered there. Let's see. How the guide is structured. Like I said, it's kind of split into two different avenues. But so the basics, we go through creating your first full stack serverless application. These chapters are roughly split up between the back end and the front end. We also talk about how to deploy your serverless application in React to production. This section of the guide is carefully designed to be completed in its entirety. Okay. And then the best practices section, we launched this guide in 2017. The Serverless Stack community has grown, and many of our readers have used the setup described in this guide to build apps and power their businesses. Okay, so it is a guide, but a workshop. Building your first serverless app. First part of this guide helps you create the Notes application and deploy it to production. So for the back end, we go through configuring an AWS account, creating a DynamoDB, set up the S3, Cognito user pools, set up the server. So we use the serverless framework. We've used that before. We also use Stripe. For the front end, it's to create React app. We set up the React router. We set up Cognito SDK to log in users. That should be fun. So can I see how to interact with the front end and the back end? Something that I'm like trying to learn more about. So that should be good. Automate back-end deployments. So okay, maybe this is the part where we sort of bring in the serverless framework, and then we've used Seed before in that other workshop for continuous integration and continuous deployment. And then it looks like there's this monitoring and debugging using a tool called Sentry. I've never heard of it, but should be fun. How to get help. So it looks like there's a forum that we can use if we get stuck or reference, perhaps ask questions. This entire guide is hosted on GitHub, so we can always create an issue or pull request. Okay, so what is serverless? The question of, probably a highly debated question in my opinion. I think it's you ask certain people and um, they might have a different like definition for it, right? So traditionally, we've built and deployed web applications where we have some degree of control over HTTP requests that are made to our server. Our application runs on that server, and we're responsible for provisioning and managing the resources for it. There are a few issues with this. One, we are charged for keeping the server up even when we're not serving out any requests. Two, we're responsible for uptime and maintenance of the server and all of its resources. Number three, we are also responsible for applying the appropriate security updates to the server. And four, as our usage scales, we need to manage scaling up our server as well. And as a result, manage it scaling down when we don't have as much usage. So for smaller companies and individual developers, this can be a lot to handle. This ends up distracting from the more important job that you might have, whether it's building and maintaining the actual application. So the processes necessary to support this can end up slowing down development times, as you cannot go ahead and build your application without working from an infrastructure team to help you get it up and running. Right. So that kind of just like describes the problem statement, right? And then like how does serverless computing come in and sort of provide this benefit? So serverless computing, or serverless for short, is an execution model where the cloud provider is responsible for executing a piece of code by dynamically allocating the resources, and only charging for the amount of resources used to run the code. The code is typically run inside stateless containers that can be triggered by a variety of events, including HTTP requests, database events, queuing services, monitoring alerts, file uploads, scheduled events. The code that is sent to the cloud provider for execution is usually in the form of a function. Hence, serverless is sometimes referred to as functions as a service, or FAS. And each cloud provider has their own flavor of functions as a service. So we're familiar with AWS Lambda. Microsoft Azure has Azure functions. Google Cloud has cloud functions, and they're all very similar. With serverless, while serverless abstracts the underlying infrastructure away from developers, servers are still involved in executing our functions, right? So there are still servers in serverless, if you didn't know that. Since your code is going to be executed as individual functions, there are a couple of things that you need to be aware of. Microservices. So the biggest change that we are faced with while transitioning to a serverless world is that our applications need to be architected in the form of functions. You might be used to deploying your application as a single Rails or Express monolith app, but with serverless, you're typically required to adopt a more microservice-based architecture. You can get around this by running your entire application inside of a single function as a monolith and handling the routing yourself. But this isn't recommended since it's better to reduce the size of your functions. We'll talk about below. So stateless functions, your functions are typically run inside secure, almost stateless containers. This means that you won't be able to run code in your application server that executes long after an event is completed or uses a prior execution context to serve a request, you have to effectively assume that your function is invoked in a new container every single time. And so cold starts, this is, you hear a lot about this, or not as much anymore actually, but since your functions are run inside of a container that is brought up on demand to respond to an event, there is some latency associated with it. This is referred to as a cold start. Your container might be kept around for a little while after your function has completed execution. If another event is triggered during this time, it responds far more quickly and is typically known as a warm start. So I think one of the other benefits, I guess we'll keep reading here. Yeah, let's just finish this off and then I have some thoughts about that. But the duration of cold starts depends on the implementation of a specific cloud provider. On Lambda, it can range from anywhere between a few hundred milliseconds to a few seconds. It can depend on runtime or language used, the size of the function, and of course the cloud provider in question. Cold starts have drastically improved over the years as cloud providers have gotten much better at optimizing for low latencies. And that's what I was going to say, is like, I think one of the benefits, it might have been an annoying thing, but, especially with Amazon, who is very customer focused, they are, obsessed with, you know, giving the customer what they ask for, and I think enough people have asked for them to figure out a better way to fix these cold starts, and um, they kind of have taken that personally, and like they're constantly trying to update it and make it better. So you can, and I think that's another one of the benefits of using a cloud provider, right? Like, you're not trying to figure out how to fix cold starts. If you wait long enough, if you're patient enough, eventually one day they'll send out an announcement on Twitter or something, and all of a sudden your cold starts are minimized and your billing has gone down. And, I think that's something to be said about using cloud providers. Okay, what is AWS Lambda? Lambda is a serverless computing service by Amazon. Uh, in this chapter, we're going to be using Lambda to build our serverless application. And while we don't need to deal with the internals of how Lambda works, it is important to have a general idea of how your functions will be executed. So Lambda specs, let's start by looking at the technical specifications of Lambda. So currently Lambda supports the following runtimes. I didn't know that they support Rust. Is that new? No way. Wait a second. I gotta look at this. So, because what we can do is you can go into. Just gonna pull up the AWS console here really quick. I'm interested in seeing that now. Let me just log in. I knew that obviously they have Node, Java, Python, but I thought Rust was like bring your own runtime or something like that. Bring your own language or something. I didn't know. I didn't think it was natively. So here's the AWS Lambda console. Uh, click on here. So I only see .NET, Go, Java, Node, Python, and Ruby. So, yeah, I don't think Rust is supported natively, but again, like you can bring your custom runtime, and it's basically just can use it in this like Amazon Linux 2. I'm not exactly sure how that works with the custom runtime, but there are ways to do it. But Rust isn't natively supported yet. I imagine that they'll add support eventually, but anyways. So this is kind of like what each of the Lambda functions use under the hood. You might notice that CPU is not mentioned as part of the container specification. This is because you cannot control the CPU directly. As you increase the memory, the CPU is increased as well. So that's just kind of like turning those knobs of performance on your Lambda function, right? So the ephemeral disk is available in the form of the temp directory. You can only use this space for temporary storage, since subsequent implications will not be accessed to this. Not accessed. The execution duration means that your Lambda function can run for a maximum of 900 seconds or 15 minutes. This means that Lambda isn't meant for running long processes. And that's a good, I think that's an important call out too. You need to know if Lambda or this serverless type of architecture fits your specific use case. So the package size refers to all code necessary in your function to run your function. This includes all dependencies in the node modules directory in case of node. Finally, here's what the Lambda function looks like. Yeah, so this is just like a screenshot of some code. Okay, so they go into explaining it down here. It's like, so here, so the my handler is the name of the Lambda function. The event object contains, so right here inside of the function, contains all the information about the event that is triggered, that triggered this Lambda. In this case, an HTTP request, it'll be information about the specific HTTP request. So like all the verbs, right? The context object contains info about the runtime of the Lambda function that is executing them. So here, and then after we do all the work inside our Lambda function, we simply call the callback function with the results or error, and AWS will respond to the HTTP request. Do stuff. Gotta tell the Lambda function to do stuff. That should be what you take away from it. Packaging functions. So Lambda functions need to be packaged and synced to AWS. This is usually a process of compressing the function and all of its dependencies and uploading it to an S3 bucket, and letting AWS know that you want to use this package when a specific event takes place. To help us with this process, we use the serverless framework. And we've used the serverless framework in other streams, but it really does, do a lot for you as far as, because I do remember a time before serverless framework where you literally had to zip up your Lambda function and upload it to S3. And a lot of manual process, whereas serverless framework has really streamlined that entire thing for you. So we'll definitely see the power of how easy that is to deploy a Lambda function. So the execution model, the container and the resources used by it that runs our function is managed completely by AWS. It is brought up when an event takes place and it is turned off if it's not being used. If additional requests are made while the original event is being served, a new container is brought up to serve the request. This means that if we are undergoing a usage spike, the cloud provider simply creates multiple instances of the container with our function to serve those requests. So you hit the front page of Hacker News, and you don't have to worry about it because the cloud provider will take care of that for you. So this has some interesting implications. Firstly, our functions are effectively stateless. Secondly, each request or event is served by a single instance of the Lambda function. This means that you're not going to be handling concurrent requests in your code. AWS brings up a container whenever there's a new request. It does make some optimizations here. It will hang on the container for a few minutes, 5 to 10 minutes, depending on the load, so it can respond to subsequent requests without a cold start. Pretty convenient, in my opinion. Right? So stateless functions, the above execution model makes Lambda functions effectively stateless. This means that every time your Lambda function is triggered, and it is triggered by an event, it is invoked in a completely new environment. You don't have access to the execution context in the previous event. However, due to the optimizations noted above, the actual Lambda function is invoked only once per execution or per container instantiation. Recall that our functions are run inside of containers. So when a function is first invoked, all of the code in our handler function gets executed, and the handler function gets invoked. If the container is still available for subsequent requests, your function will get invoked and not the code around it. So for example, the create new DB connection method below is called once per container instantiation and not every time the Lambda function is invoked. The myHandler function, on the other hand, is called on every invocation. So this is called once per container instantiation, and then the myHandler function is called every time the Lambda function receives an event. This caching effect of containers also applies to the temp directory that we talked about. It's available as long as the container is being cached. So now you can guess that this isn't very reliable to make our Lambda function stateful. This is because we don't control the underlying process by which Lambda is invoked or its containers are cached. So I've read a few times before that Lambda is really meant to be this glue component. They could have named it AWS Glue, which it's actually the name of another service, but I've read that it's they could have named it Glue because it's more of how Lambda can sort of bring all these other services together based on from a triggered event. So pretty interesting. So pricing, finally, Lambda functions are built only for the time it takes to execute your function and is calculated from the time it begins executing till when it returns or terminates. It is rounded up to the nearest 1 millisecond. And I think that's a recent update from AWS. I think it was previously like seconds, and now it's milliseconds, I believe. Note that while AWS might keep the container of with your Lambda function around it after it is completed, you're not going to be charged for this. So it's only the amount of time it takes to execute your function. So Lambda comes with a very generous free tier, and it is unlikely that you'll go over this while working on this guy. So the Lambda, unless for some reason, again, like I said, if we build this and then it somehow goes viral on Hacker News, we might have to pay a few bucks or something. See, I doubt it. Okay, so let's see. So the free tier includes 1 million free requests. So there's no way per month, and 400 gigs of compute per month. Past this, it costs 20 cents per 1 million requests, and 0.00001. Yeah. So I mean that is another compelling reason to use a serverless type of architecture, right? Because you can see the cost benefits of not managing infrastructure, and then on top of that, the price of what it takes to run Lambda function. I mean, I'm surprised more people aren't thinking like serverless first and then. So in our experience, Lambda is usually the least expensive part of our infrastructure costs. Okay, so why create serverless apps? It is important to address this why it is worth learning how to create serverless apps. There are a few reasons why serverless apps are favored over traditional server-hosted apps. So we mentioned like low maintenance, low cost, easy to scale. The biggest benefit by far is that you only need to worry about code and nothing else. The low maintenance is a result of not having any servers to manage. You don't need to actively ensure that your server is running properly or that you have the right security updates in. You deal with your own application code and nothing else. The main reason it's cheaper to run serverless applications is that you're effectively only paying per request. So when your application is not being used, you're not being charged for it. Let's do a quick breakdown of what it would cost us to run the note-taking application. We'll assume that we have 1,000 daily active users making 20 requests per day to our API and storing 10 megs of S3 files in S3. That's like best case scenario, but we'll see. So, I mean, it breaks down, and you can see here that Cognito there's a free tier for Cognito, as well as Lambda. So API gateway, $2.20. And then DynamoDB would be $2.80. Yeah, and I mean, again, this is assuming that we have 1,000 daily active users, but you can imagine. I mean, I'm probably get from my own activity or trying to invoke it. I mean, it's going to be a lot less than that. So at most, it'd be $6 to run this application. So that comes out to 6 months per month, or $6 per month. You can also, buy a .com domain in Route 53 for $12. But yeah, I don't think that's necessary. Finally, the ease of scaling is thanks in part to DynamoDB, which gives us near infinite scale in Lambda that scales up to meet the demand. Okay, great. Now that you're convinced on why you should build serverless apps, let's get started. I mean, I was already convinced. I don't know what you're talking about. All right, so here it goes through creating an AWS account. So we already have an AWS account, but it's nice that they kind of go through this and teach you about once you've created an AWS account, and it's very in depth of like how to create a user and then logging in as the user. It's all good stuff. And then configuring your CLI. So if you haven't already done this, I'm gonna probably click through this since we already have this set up on my workstation here. And we do have, let me see if I can. So SLS is just a short. SLS is like a short version of the serverless framework command, right? So I have it installed here. Like I said, pretty easy to get it installed here, and it goes through how to install it. Oh, it looks like we're okay. So we're jumping straight in here. Oh wow. Okay. I was thinking we're just still part of the setup process here, but it looks like we're going all in. All right. So now I gotta we're gonna write some code finally. So let's see. Okay, so we have the serverless framework installed, right? So if we just see through that. Okay, so we are going to run this command here in the working directory, create a project using a Node.js starter. We'll go over some of the details in the starter project in the next chapter. So let me just go into my projects directory here, and then I'll just run that serverless install from the Node.js starter repo on GitHub. So then it should have created a Notes API -API project. So if we cd into Notes, okay, so now I'm actually going to open this up in code editor for VS Code. See what it looks like. Okay, so now in the directory it should contain a few files, including the hammer.js and the serverless YAML file here, move this over. Yeah, so it's good. It's a bit of boilerplate code to get us done, right? And not much going on here except that it's just a few things, right? So we also have a test directory. Okay. Nice. Testing is always good. Something I never consider until after I should have included tests. It's always an afterthought. We are we are changing in 2021. We're going to change that. Okay, so we need to install the dependencies. Right? So if we open up terminal and then type in npm install. So next we'll install a couple of other packages specifically for a backend. So it looks like we're going to add the AWS SDK and a unique identifier package as well. Uh, that will help us storing things to DynamoDB. I ran out of coffee, but usually every time I run npm install, I usually take a cup of coffee. Sip of coffee because it's a good time to pause. Npm install is my computer, my laptop going nuts right now. Fans are, it's like good thing it's cold outside because this thing is giving off heat. So keeping me warm there. Anyways, I guess that last still going on. Keep wandering around this directory. So our package got this on didn't think npm install was going to break my computer. Struggle lesson. Classic. Okay, let's try to move forward a little bit while it's still going. So update the service name. So let's change our name of our service uh, from the one starter. So if we go into our serverless file, we come back and install the SDK and the okay, so yeah, that's fine. So we're gonna update the version node to 12 and then straight to prod. Okay, the service name is pretty important. calling a service with a rates API. So we're gonna have to change the name of the API. But serverless framework creates your stack on AWS using this name. So this means that if you change the name of the project, that does sound pretty good. We're also defining one member function called below. It has an element called below. It follows the format. So in this case, the handler for below member function is the below function that's executed in the backend. You can see that. So the name of the file is handler and the name of the function is so our lambda function also responds to an instance get that if it has cache below, this will make more sense after the deploy API. You'll notice that the plugins that we created are Serverless Stack Bundle, Serverless Stack Offline, and Serverless Stack plugin. The Serverless Offline plugin is located for local development, while the Serverless backend plugin is loaded to load document files to handle environment variables. On the other hand, the Serverless Bundle plugin allows us to write a lambda function using a flavor of JavaScript that is similar to the one we're using in our front end. So let's save this. And it looks like also let's install the AWS specific plugin. And then we'll install the okay, so so far. So add support for add support for ES6 and TypeScript. So Lambda supports Node 10 and 12. However, supported syntax is a little different compared to Emacs. So Emacs script, flavor of JavaScript that frames React app support. It makes sense to use similar ES features across different parts of the project, so that we'll be relying on ES imports, exports, and functions. Additionally, our frame React app automatically supports TypeScript via React. And while we're not using TypeScript in this guide, it makes sense to have a similar setup for our backend functions, so you can use to do this, we typically install Apple TypeScript like that. A long list of other packages. This can be a ton of big and complexity to the public. To help with this, we created Serverless Bundle. This is a serverless framework plugin that can do two things. So, only one dependency, which is a long list, I will say. Supports ES6 and TypeScript, generates optimized packages, maintain Lambda functions using ESLint, supports transpiling unit tests with AWS, support source map, support for proper error messages. It's automatically hidden in starter projects and each chapter, the TypeScript, and also have so there's a TypeScript starter as well. So we already have the element, which is kind of confusing. So if you look at our it's probably have the one that it's already installed and we're using it as a plugin for serverless menu file. And then back in this it's already part of that function. So let's look at the Lambda function that comes with our starter object. So yeah, this looks exactly the same. And we can actually we can invoke this Lambda function locally. I'm curious to see like if this works without configuring CLI gallery. Um, yeah, okay, so oh, I mean it still works, but you say oh okay. We need to change this and create our own .env file. But anyways, so that was just kind of like a warning message up here about some deprecation warning. A couple of deprecation warnings showed up. But the point is that when you're able to get the status code of 200 back, and you're able to see that you got the message that is coming from so in the above command, we're asking the serverless framework to locally invoke the Lambda function called hello. This in turn will run the hello method that we're exporting from our main.js. I was kind of hoping that it would go through maybe like how the serverless framework is doing that on the thought it used like Docker, and that was pretty fast too. It's a small function, but was so we're directly invoking the Lambda function. The once deployed, we'll be invoking this function to deploy into that endpoint. Now we're almost ready to deploy our Lambda function API, but before we do, let's quickly look at one of the other things that we set up for the starter project. Optimize packages by default. By default, the serverless framework creates a single package for your Lambda functions. This means that when the Lambda function is invoked, it will load all the code in your app, including all of the other Lambda functions. This negatively affects the performance of the app loads inside. The larger your Lambda function packages, the longer the code storage. To turn this off and ensure that the serverless framework is acting your functions individually, add the following to your serverless.yaml file. This should be, yeah, so it's already in the default. It's already added by default. So, note that with the option above, serverless bundle can use Red Hat to generate optimized packages using tree shaking output. It will only include code needed to run the main function. So now we're ready to deploy. So far, we've configured AWS account, so it's what we that. Okay, so that's big advantage of serverless is that there isn't any infrastructure or service required. You simply deploy your application directly and serve to millions of users. You might have one, but I think we're very optimistic here, and this could be but so yeah, now we can just run serverless. So like I said, SLS, you can write SLS as well, and uh, this can be a shortcut for the same as like running a serverless. So SLS deploy. The first time your serverless app is deployed, it creates an S3 bucket to store your Lambda Lambda API and other resources. This can take 1 to 2 minutes. Once complete, you should see something like this. So we'll basically get this API endpoint eventually, and then we can open it up inside of our browser, and you should get the same message that we got locally. So, so yeah, this would be the first serverless API. I do like how it starts out with using the starter project to sort of get us up and running quickly, and then we'll just sort of iterate on top of that to build out this serverless application. So far, I'm really impressed with the quality of this guide or workshop. It seems like we've done a really good job of keeping it updated, and within this first hour or so, before we quite a bit. Inner workings of creating a serverless application, some of the benefits that it provides. And I think it's right off the bat showing how easy it is to use a framework like serverless framework to just quickly deploy code to a provider like people. So far, so good. And then, yeah, I mean, on the back end, so while it's saying, it doesn't mention it really. Yeah, it doesn't mention it in the guide, but here you can see while serverless is sort of doing its thing, it is actually using CloudFormation to, as like the deployment mechanism, right? So, the serverless framework kind of is like a abstraction, so to speak, of writing just raw CloudFormation to build the same exact thing. Because if you're writing the CloudFormation, essentially you could do the same thing and write the CloudFormation to do what the serverless framework is doing. However, it would just look a little bit more, it just looks a little bit nicer, a little bit easier to develop because you're able to just kind of, right, this is a function, this is the handler that I want to use, and events or methods that I want to include, rather than like that raw confirmation where you're just one to one. So, anyways, we got our endpoint here, and if we open this demo, we should be able to see and did. So we were able to see that we got the same message. Now this is actually deployed inside of our. Oh, here. So yeah, here this is our Lambda function, right? So serverless, the serverless framework, just it deployed this for us, and it provided this API gateway and Lambda function here in the AWS Lambda console, and it only took this handful of lines to do that. It's the same thing that we were able to develop here locally, and then running serverless or SLS deploy, and then now we get this endpoint with the Lambda function to provide our message here. Pretty cool stuff. Pretty cool stuff. All right. So now, before we start working on our app, let's create a GitHub repository for this project. Again, this is pretty fundamental, especially nowadays. You need to be storing your code in GitHub. Super important. Let's see. So it looks like we're going to go and create a repository, and then I guess we're just going to be pushing up the code that we just. Yeah, I mean, so if you've never done this, so up here on GitHub, I think. Okay, so yeah, if you go to your GitHub page, I've already logged in, right? And there's this little plus button here. You just hit that and create a new repository. And what did it call? Serverless stack so serverless stack. And I'm pretty sure this can be public. That should be okay. We're not putting in sensitive information. And then you want to hit like this clipboard here to get the URL of our repo. And then we go side by side here. We'll go back into the terminal of our serverless application. And then go up here and we'll say and then like it says here, so we need to initialize the repo, so git init. And that just adds like a this .git file. And then we want to say git add all of our existing files that are in this project. And then we need to say git commit -n first. It's the message for our commit. And then git remove and then the URL that we just copied from our clipboard. And git and finally we can just push it. Big change to name. I feel like that means GitHub recently got rid of the default branch being master and they moved it to main. So maybe we can help them out and create a merge request for this way. Anyways, that's okay. Okay, so next. So yeah, let's see where we're at. So it looks like we've gotten through like setting up, the introduction, setting up our AWS account. We went through setting up our serverless app. We were able to kind of go through setting up or using that starter project to get going with local development, and then finally actually deploying our serverless API to AWS, and then being able to trigger that event through going to the endpoint and seeing our message here. Yeah, so I think that's where we'll stop today, and then we'll keep building in part 2. It looks like we'll start creating more AWS resources and building around the serverless API that we're creating. Yeah, so I think it was a good first start, and we'll keep building. So thanks for watching, and I'll see you next time.